Welcome learners. We are looking at the elementary operations. Alright, in the last video we have seen the elementary row operations like 3 here we have defined the interchange of two rows, and secondly multiply a row by a non-zero constant number and add a multiple of a row to another row. Okay, and these are the notations which we have accepted. Okay, so when you go for any other text, please see the notation, what notation they are using. Okay, they may write rk plus kj changes this results to ri, something like that. Okay, so whenever you refer to any text, please see the notation, what notation the author is following. In the last video we have seen about echelon forms, right? So we have seen row reduced echelon form and row echelon form in some examples we have seen, right? So today we will use these row reductions to get the inverse of a matrix. Okay, so first let me define what is the inverse of a matrix. So matrix inverse of a matrix. So of course, to define inverse you need a square matrix. Also for triangular matrix there is something called as generalized inverse, but we will not talk about it. Let us take a square matrix A. So let A be a square matrix, say of order n, say n by n square matrix, if there exists matrix B of order n such that A into B is equals to identity, which is same as B into A, then B is called inverse of A. Okay, and then we have the theory of invertible matrices, like A is invertible if and only if determinant of A is not equals to 0, and then we again have the formula to get the inverse of a matrix. Alright, this we have seen when we have written the program for Python program for getting the inverse. And if you want me to write the formula for getting the inverse, we have A inverse is equals to 1 upon determinant of A into adjoint of A. How we get this? That also I can tell you. Let me take a minute to show that. We can prove that A into adjoint of A is nothing but determinant of A into I. Okay, we can prove this result. And once you show this, we can say that this, you can take this determinant here, then A into adjoint of A upon determinant of A is equals to I, and hence 1 upon determinant of A into adjoint of A is nothing but the inverse of A, that we can say. Okay, but today let us go and use row reductions to get the inverse of a matrix. Okay, so let's go further. Now let us take a matrix A. Okay, so let A be a square matrix. Okay, to find A inverse, we take the augmented matrix. Okay, let me tell you what is augmented matrix. Augmented matrix, we take the augmented matrix as AI. Okay, we will take matrix A here, okay, and I here of the same order, identity matrix of the same order. Then we will apply row transformation on A and make this A as identity matrix, and the same operations will also apply for I, and that will change to some other matrix, and that matrix is nothing but inverse of A. Okay, let me just directly go for the example, that will make the example clear. Okay, let's go here because we need many transformations. So let's start with find Question: find the inverse of a matrix of a matrix A. Let us use 3 by 3 matrix. Okay, 1 2 3, 2 4 5, and 3 5 6. Let us take this matrix, 3 by 3 matrix. Now it is not always that this is invertible matrix, right? It may happen that the inverse of this matrix does not exist. When that will not exist? When the determinant of A is equals to 0. So if determinant of A is equals to 0, the inverse of this matrix will not exist. Okay, but we will not check what is the inverse, what is the determinant of A. We will directly apply the row reductions and see if it is invertible or it is not invertible. Okay, so find the inverse of a matrix of A is equals to this, or show that if the inverse does not exist, then show that it does not exist. Okay, so in the process we will come to know when it will exist or when it will not exist. Okay, so let's go for solution. We need the row reductions. Okay, elementary row operations. So first let us form the augmented matrix. Form the augmented matrix. Okay, that is A I. Let me just give a partition out here. I'll just put this like this. Okay, so we will put matrix A, we will put a matrix I. And what is this matrix? This is nothing but, we will take matrix A. Matrix A is 1 2 3, 1 2 3, 2 4 5, 3 5 6. Okay, let me not complete this. And if you notice, this is a symmetric matrix, right? 1 2 1 4 6 is here. When you take the transpose of it, A and A transpose is same here. So this is a symmetric matrix. But anyways, that won't. And let us take I here. What is I? I is the identity matrix. Let us use another color for I. Let us use this color. 1 0 0 0 1 0 0 0 1. Okay, and this will be your augmented matrix. And let us use simple partition kind of things like this. Now what we'll do is apply row operations on this matrix and try to make this matrix a identity matrix. Okay, so same operations will also apply over here, and in the process, suppose you are getting that one of the row of this matrix is entirely 0, then you cannot convert that matrix into identity matrix, and hence the inverse does not exist. Okay, I repeat, in the process of converting this into identity matrix, if you came to the step where you are getting a particular row which is entirely 0, then the inverse does not exist. Okay, so let's move ahead and apply row operations on these matrices. We want to make this as an identity matrix. So what we'll do is, we'll go column wise. First make this one rest to zeros, then make this one rest to zeros using this one, and then make this one using this one, make this to zeros, and apply the same operations over here. Okay, so let us proceed. We will use some other color. Let us write this. So let us first apply the operation. We'll make this term 0. Okay, let us make this 0 by using this. And to make this 0 by using this, you will change our value R2. R2 will change to R2 minus 2 times R1. Right? First we already have 1. If this 1 is not there, somehow we will adjust it and make it 1 here. And as I said in the previous video, as far as possible, try to avoid the fractions. Otherwise, again, you need some time to calculate the fractions, do the calculations. Okay, so by using this one pivotal 1, we will make this 2 as 0. Okay, so let's apply this operation over here. So we'll have a matrix of order 3 by 3. Let us put this like this. So first row will be as it is throughout. So 1, 2, 3. Third row is also same. So 3, 5, 6. Also for this side also, this is first and third row same. Say 1, 0, 0 and 0, 0, 1. But our second row changes, right? Our second row changes such that you are taking second row, you are multiplying the first row by 2 and subtracting. So 2 minus 2 times 1, so it is 0. Okay, 4 minus 2 times 2, again that will be 0. And 5 minus 3 times 2, so minus 6, 5 minus 6 is minus 1. Okay, same operations you have to perform here. So 0 minus 2 times 1, so minus 2. Let me use a color for that. This becomes minus 2. Then 1 1 minus 2 times 0, so again it will be 1, and 0 minus 0 will be 0. So this is our first operation. Okay, now again by using this 1, first row will make this 0, and for that our operation will be R3 changes to R3 minus, we will take 3 times R1. Okay, now again make one point clear that to make this 0 we will use the first column, first entry here. To make this row 0 we will make the entry here which is A22, then we will use A33. Okay, that is the standard procedure which we will follow. Okay, so with this operation we will get a matrix that is right here. Is again 3 by 3 matrix, and in this case now 2 and 1 and 2, first and second row will be as it is. So let us write first and second row 1, 2, 3, 0, 0, minus 1. Let us write this also. So 1, 0, 0, minus 2, 1, 0. But our third row is changing. How the third row will change? We are taking this row, third row, we are multiplying 3 to the first row and we are subtracting. So 3 minus 3 will be 0. 5 minus 3 into 2 is 6. 5 minus 6 is minus 1. 6 minus 9 is minus 3. 0 minus 3 is minus 3. Oh, let me use the color. This will be minus 3. Then 0 minus 0 will be 0 and 1 minus 0 will be 1. Okay, now next job you need to make this entry 1. Okay, and for making this entry 1 you can use these rows. Okay, now what we can do is there's already 1 here. What we can do is you can interchange the second row and third row. Okay, so and then you multiply by minus 1, you will get the desired result. Second option is you take this second row and you subtract the third row over here. So 0 minus minus plus 1, you will get 1 here. But remember our aim is to get 1 here. Okay, so let us interchange the rows. So interchange R2 and R3. Let us interchange. Second and third row is going to change here, but first row will be as it is. So 1, 2 and 3. Now you will interchange these rows. So second row becomes third and third becomes second. So 0, minus 1, minus 3 and 0, 0, minus 1. And same operations will be over here. So first row is as it is. 1, 0, 0. This becomes minus 3, 0, 1 and minus 2, 1, 0. Okay, this is by interchanging the second and third row. Now what we need to make this 1. Okay, and to make this 1 we can multiply the second row by minus 1. Also we got 1 here, minus 1 here. we can multiply this third row also by -1. We can operate both the transformations together if we are not getting confused. Okay, so let's operate both the transformation together here. So let us write R2 will change to -1 times R2, and R3 will change to -1 times R3. So as far as you are not getting confused, you can perform two elementary row operations together. Okay, you can perform these two row operations together. I should not use elementary term because it is reserved for something else. Let us write row operations. So the first row is not going to change. So 1, 2, 3, and then this side you will have 1, 0, 0. Second row we are multiplying by -1, and also third row we are multiplying by -1. So let us complete this row. So 0, this will be 1, this will be 3, this will be 0, 0, this will be 1. Then this -3 becomes +3. You are changing the sign. So 3, 0, -1, and 2, -1, 0. These after performing these two operations. If you are getting confused, you can perform these operations one by one. Okay, this we can perform because both are independent of each other. Okay, next, by using this one, we make this 0, and by using this, we make this 0 and use this 0. Okay, so let's make it. Now R1 will change to R1 minus 2 times R2. Okay, that will change, that will make this 0. Okay, let us write that, perform that one operation first here. So this will give you R1 changes. So second and third row will be as it is. So 0, 1, 3, 0, 0, 1. And this side will be 3, 0, -1, 2, -1, 0. Okay. Now our R1 changes. R1 changes by 2 times R2. Right. So 0 into 1, it will be 1 here. 2 minus 2. This will be 0. 3 minus 3 into 2 6. So this is -3. Okay. And similar calculation this side. 1 minus 6. That will be -5. 0 minus 0 will be 0, and 0 minus plus 2, so 2. Okay, this is by making that corresponding operation. So we made this 0. Okay, now let us make this 0. So this is 0, 0, 1, 1, 0, 0, 0, 1, 0. Now we need to make this 0 and this 0 by using this one. Okay, so let us perform both the operations together if you are not getting confused. Otherwise, that will again increase the length of the video. So R2 will change to R2 minus 3 times R3. Right? Remember, for changing, we are not using the first row, so we can perform the other operation as well together. Let us take one by one. Better not to get confused. So first row as it is, so 1, 0, -3. Third row as it is, so 0, 0, 1. Let us complete this part also. So -5, 0, 2, and 2, -1, 0. And R2 minus 3 times R3. So this will be 0 here. This is 0 here, so this will be 1. And 3 minus 3 times 1, so this will be 0 here. Now correspondingly, what we will have here is 3 minus 6, that will be -3. Then 0 minus plus 3, so this will be 3, and -1, and this is 0, so again we will have -1. Okay, so we got, now what our last job is to make this is 0. So let us use the operation now. We will use operation R1 will change to already -3 we have. Okay, So to make this, we have minus 3, correct? If any error, you can rectify the error. So from here we got this, and R1 changes to 2 times R2, so this will be 6 minus 3. So now this R1 will change to R1, already minus 3 is there, so plus 3 we need, so 3 times R3. Okay, and with this we will get the identity matrix here. So 0 0, this will become 0, sorry, 1 0 0, this becomes 0 1 0 and 0 0 1. We are not doing anything with the second and third row. Okay, again here we are not doing anything for the second and third row, so this is minus 3 3 minus 1 2 2, sorry, minus 3 3 minus 1 2 minus 1 0, and this will change. How it will change? R1 plus 3 times R3 here. Okay, so 3 into 2 is 6, minus 5 plus 6 will get 1. This is 0, and this is minus 3 plus add, we get minus 3, and 2, then this is 0, so it will be 2. And let's complete this matrix. Okay, so what we have done is we got this as 1 minus 3 2 minus 3 3 minus 1 2 minus 1 0. Okay, and this is, we can write this is same as this is same as this is I identity matrix, and this will be A inverse. Okay, so we have this identity matrix. Let me just write like this for your understanding of the partition kind of things. Even if you don't write, there is no harm, just for your understanding. Okay, so this implies, what is the inverse of A? This implies A inverse exists because we are not getting any entirely 0 row, and A inverse will be equals to this matrix, the yellow one. So it is 1 minus 3 2 minus 3 3 minus 1 and 2 minus 1 0, and this is nothing but a matrix from here. Okay, so this is how you use row reductions to get the inverse of a matrix. And as I said, in this process, suppose we are getting a row which is entirely 0, then the inverse does not exist. So better we break, and we will take another video wherein we will get a matrix whose inverse does not exist, and we will show it by using row reductions. Okay, so see you in the next video.